Nice to see everyone here. So we'll be continuing with part 2 of FHE in AI. We have some terrific panelists for you. So I think to begin, before we jump into questions, it would be great to hear a bit about everyone's background on the panel. So perhaps a little bit about yourself, your company, maybe you can begin.
Sounds great. Good to see everyone this afternoon. I'm Brendan. I'm the technical co-founder, CTO of Masa. At Masa, we built or have built a decentralized AI data network where we have miners and workers that scrape various data sources, whether it be Twitter, web data, Discord, Telegram, do speech-to-text conversion for things like YouTube videos and content, as well as podcasts, and make this all available at scale with one of what we believe is going to be the biggest open source data set in the world. Currently, you'll find it on Hugging Face or through our platform. Millions of tweets, tens if not hundreds of thousands of hours of YouTube content, podcast content, so on and so forth. And for anyone that wants to get up and running with like RAG applications for agents, fine-tuning, pre-training, any machine learning application where you might want to use data as your input, you can come, get access for free, and start building out the gates.
My name is Jen, and I'm from Kip Protocol. And Kip Protocol is aiming to be the Web3 base layer for AI. And that doesn't mean we are going to be an L1. What it means is we're going to be providing the tools and the infrastructure that AI developers need if they want to deploy quickly and easily into Web3. So what we're going to be is essentially sort of the WordPress or the Shopify for AI in Web3. Letting people put their stuff out there and get paid whenever someone uses it.
Hi everybody, I am Alan. I am the co-founder and CEO of Game Plus. Game Plus is training AI tools and agents for the gaming industry. What we do is we provide dev tools such as 2D, 3D asset generation, animations, NPC dialogue, narration. We also have a layer which collects user data as they play games, as they interact with our ecosystem. We reward users for their behavioral data in order to improve our models as well.
Hi everyone, Liam from Morphic. So I'm now CEO and co-founder of Morphic, and we're actually a secure AI inference layer for the Web3. So nowadays actually we have a lot of projects working on decentralized AI. It's like those kind of new infrastructure specialized for AI system, and we try to bring data on chain and model on chain, and also a lot of kind of incentive system on chain. So there's a lot of security concerns, just like confidentiality and the fairness, and also the availability of your autonomous of your data, things like that. So we are solving the problem we're solving is like to empower existing DI infra and also even trading AI infra to enable their service with confidentiality and availability guarantee. So this is what we call the secure AI inference.
Great stuff, everyone. So let's jump into our questions now. I think the first one is a bit of a broader question. Everyone, of course, has heard of centralized AI versus decentralized AI. It'd be nice maybe if we can explain to the audience some of the differences between the two, the pros of decentralized AI over centralized, and where FHE comes into play.
I don't mind getting kicked off. So from my perspective, I think it boils down to one key element, which is the alignment of incentives. We all work and operate in a world where programmable incentives are at the core of many of these blockchain systems. You look at a platform like BitTensor, which incentivizes different subnets through almost like a survival. If you don't compete well, if you don't provide value on the subnet, you will be rolled off and replaced with another subnet. Same within the subnets with miners. There is this constant game that's being played to produce the highest value commodity within like a machine learning context or an AI context. Maybe that's synthetic data, maybe it's deploying H100s, A100s to power models on subnet 19, or maybe it's like a Masa where we scrape huge volumes of data and make that available. So for me, decentralized versus centralized is very simple. You simply cannot create those aligned incentives in a centralized model. GPT 01 is kind of really refined on a lot of our prompt data, and when we think about how FHE fits into AI, it can be things as simple as ensuring that the prompts that you use within these systems are encrypted, and then when models are trained on them, we're using FHE maybe to ensure that the underlying data there is not actually revealed, because some of our prompts might be sensitive, some of our prompts might be revealing information that we want to keep private, and this kind of privacy layer is really important, being able to deploy that on this really, really powerful incentivized economic layer brings privacy plus alignment together.
Yeah, I would 100% agree with that, I think. And there's obviously, as many takes on what decentralized AI is as there are individuals in the space. I was going to say companies, and not even companies, because within companies people have different takes. But yeah, what I would say is that the reason all of these takes are so important is because, partly at least, because there is a lot of them. Because if you leave this up to the huge companies like the Googles, the OpenAIs and so on, what they will tend to do is they will get fixated on the one thing that they've come up with and the one way of doing things. And then they will just go down that rabbit hole and get stuck. And we've kind of seen that with Google. So they had the Transformer paper and they were way ahead of everyone else. And then they got obsessed with safety and OpenAI just lapped them. And then the same thing does kind of look to be happening with OpenAI right now. They keep doing these very hyped announcements with none of them ever turn out to be 5. It's all these strawberry, a Q, whatever it is, and very thin veils for the fact that 5 is just not possible right now. So and obviously what they're doing is that they're doubling down on the method that they have, which is this reinforcement learning and so on. But what we know from having worked in AI for so long is that the best way to solve a problem in AI is to span solutions, not to try and craft this one perfect solution forevermore. And what decentralized AI does is it encourages people to span solutions, and that is the method that you need in this domain.
Yeah, I also agree that there's a lot of ways to decentralize AI. We see a lot of projects doing decentralized knowledge bases, data sets, computing power, inference. There's many ways you can go about decentralizing. For Game Plus, coming from a game developer background, we kind of realized one of the most important things about AI is gathering data, right? A lot of these large companies are actually running out of data. There's not enough on the internet anymore. For us, because we're focusing on a very consumer-focused vertical of gaming, we saw that there's no gaming data on the internet, right? It's all controlled by large game publishers. If you don't have a game that's popular, you don't have people generating game data. So for what we're trying to do is we want to partner with smaller companies such as indie game developers to kind of aggregate all of their data together, right? So this is our use of the decentralization. To do that, we can pretty much rival these larger data, collectors.
Okay, so centralized AI versus decentralized AI. So my news here is like, I think at the beginning, I think decentralized AI is more like, I would say, a belief, because we believe in the culture of decentralization and also the culture of fairness. So we propose, some kind of idea like decentralized AI. But after some kind of more thorough analysis and also understanding of the market and the technology, actually, I think now, we are doing, or what's the advantage of decentralized data is more about some fundamental things. For example, in the centralized AI or ES, there are a lot of kind of pioneers who propose, the famous transformer framework, and build, I would say, some kind of a concept for the new AI future. But in terms of, I would say, a product or a trustless work, actually, nowadays, just like the traditional finance system, you can cut off your users from using the system anytime for any kind of reason which you believe is reasonable. And now in the centralized AI world, OpenAI can also cut off your visiting to their model. And now, by decentralized AI, we actually can transform this kind of technology or belief to some real benefits for users. For example, the availability, the high availability for the AI service, and also by decentralizing the AI system and by introducing the incentive system, actually you can encourage more users to contribute data to build I would say, more advanced AI model, and also build a more active community to develop more, I would say, specialized or useful model. All this kind of thing can transform the simple belief on decentralization to some real benefits to the model service, the AI service itself. So this is.
I'll just add one thing, I think, to kind of feed off what you're saying. Censorship resistance is so critical in this space. I don't know if any of you followed the jailbreaks that were done on O1 over the last few days. The red teams that did that instantly had their accounts suspended. This was for like calling out very valid attack vectors for jailbreaking O1. And not just the way in which these centralized companies are defining the reality that we observe and understand through the information we get back from these models, they're also having a huge amount of control over who can actually interact and converse with these, human-like interactions. We have to have censorship resistance in this space and equal and fair access for everyone.
Couldn't agree more. Yeah. So let's drill down a bit into some of the technologies that are underpinning the AI, specifically FHE, to honor the moment in the day. So let's take the audience through a bit about the advantages that we see with FHE and some of the challenges for widespread adoption.
Let's go first.
Yeah, sure, I can go into this. This was one of the first things that came up actually when we started building Kip. The fact that we've got clients who want to offer their data, we've got clients who want to train models, and then we've got how do you put those two in contact and get them interacting with each other if neither of them knows who the other one is and they can't trust each other and they're on different sides of the world. So FHA is kind of one way to get around that problem and solve it. I think it's kind of the holy grail for decentralized AI, because right now we can decentralize the components and then we put a whole lot of effort into making sure that they're secure once they're actually decentralized. And, if someone is accessing their data, they can't copy it. If someone is accessing your model, they can't steal the weights, etc., etc. And the problem is, just same as always in AI and also crypto, speed. I think speed is the killer.
Yeah, Web 2 AI is going at breakneck speed. I don't think any of us in this room have seen anything as fast in our lives, and we'll never see something as fast again for the rest of our lives. And when you think about what everyone's doing here, there's themes around ownership of data, being able to monetize your data, having open access to AI in these models, open weights, protecting data. And if you think about the way that FHE can allow you to build a consortium, for example, of members, where they can pool resources, that resource being data together, and allow the training of models on something like personal data, which is inherently extremely challenging to aggregate together. Getting enough people to opt into a system where you can actually train a model on individual data is like getting blood out of a stone. It's very, very hard and can cost a lot of money. So FHE, while it's very expensive computationally right now, we're very, very early. The cost of computation is the main barrier here, and you probably heard that all day. In order to be able to do calculations and compute on data without revealing it through FHE can really apply to one of these great use cases, which is how do we take an entire population of data that's built together around a consortium and build more personalized AI, which is what Apple's going to do with their sort of on-device inference. And we should have other providers sort of giving that to the world.
So for us, the cost is also, I guess, the biggest challenge for FHE. Because we're collecting a lot of behavioral and personal data, we kind of have to figure out what type of data we want to encrypt with FHE, what type we don't need to, and that's something we have to talk to the community about. Some people are very sensitive about how they spend their money, or what they say in a game even, especially for some of the games that we're making, there's a lot of role-playing involved. So some people are very embarrassed about this kind of data. They don't want to kind of let people see what they're talking about. This is something very important to us as well. So our biggest challenge is just figuring out what type of people want what type of data to be revealed.
And I think I could add on from a more technical view. And so basically, I think what FHE can contribute to AI definitely is about the conditionality. Because I mean, with I would say emergence of FHE, that actually could be the unique, ideal way which can guarantee the confidentiality purely based on mathematics. Because before we have TE, we have FHE, we have MPC. They are either based on hardware trust or major honest majority assumption. So they are not. Neither of them could be, I would say, stable enough. So now FHE is purely based on mathematics. So it's just like ZK is meaning to the verifiability. So that's the first thing. From a concept aspect, and that actually lead, I would say, an ideal goal for all of us to draw on and to contribute to, and then to be more down to earth. Yes, currently FHE is so costly. So to adopt FHE to bring that into the world of AI, you actually face several very practical problem. So for example, you may need to consider, okay, for those AI scenario where the model could be not very complex, it's simple enough, and also you don't need a lot of interaction with the model. For example, I don't expect any immediately response. I can endure, for example, if just for image generation, so it's okay for me to wait for several minutes. It's not a large language model where I want to communicate with the model. Round by round immediately. So first, that should be less interactive, and then in that scenario, it's better. Okay, you may have some very important data to guarantee its security. So anyway, that's where we need to consider when you apply FHE for AI, and maybe more technical part I could decide later. Yeah.
This next question actually for the technical part. So good segue mentioning ZK. Of course, there's many different technologies when it comes to confidential computing, not just FHE. There's trusted execution environments, there's zero knowledge proofs, as you mentioned, there's differential privacy, FHE. So I guess I'm curious, what type of criteria do you consider when selecting which technology to use? And maybe you can elucidate a bit about what you've done in the past at your company for that technology, and if it's in production, how it's working.
Yeah, I can jump in again. So Kim's whole goal is to basically put this onto the users. And what we're trying to do is to build a system where you have your asset, whether that is a data set, a model, whatever, and you have KIP standard APIs, which are running on the same server or a connected server. And what those APIs do is, rather than using paired API keys, they use on-chain data to basically token gate access to this thing. So they check that the person who wants to get in has the right token, he has the money, etc. It's all legit, and then he can connect and do what he wants to do. But because it's all on the servers of the providers, they can add or remove other requirements as they wish. So for example, they can set up the APIs and have an API key on top of that if they want, if for some reason they need that. Or they can have their own encryption systems that only people who are within their system can decrypt and so on. So yeah, what we're trying to do with this is say, yeah, let 100 flowers bloom. You encrypt your own stuff your own way, and we will provide the connectors that you need to then let the approved people in.
Yeah, I think this is interesting. After, with Masa, we started off encrypting and making personal data available to organizations. So we get a bunch of people, you'd connect your personal data into like a backpack. We'd encrypt it, we'd put it on chain with a zero knowledge, as we called it, soulbound token. We encountered a couple of design considerations and also practical considerations when we were shipping this product. We discovered that on the demand side, there is limited demand for this kind of encryption because we found that companies don't necessarily care about this level of privacy at this moment in time. So I question sometimes whether we're too early with some of this for the actual consumers of this data, and then the end user as well doesn't always care about having their data private. I think most people in this room have used some centralized AI service, happily putting all of our prompts that's effectively like recording this conversation without consent and then using it for whatever means you want from a centralized perspective. We've done that for years with advertising, with like the social media platforms. People will happily do that for a very long time. It comes down to cost, scalability, latency, and all these design considerations. I think the most valuable source of data, financial, identity, like PII type stuff that's subject to GDPR, will likely fit this product much better for FHE and Nesa.
Really quick follow-up question, because I think the demand for security technology like this is very important for us to consider and address. Do you think the most important thing for us is evangelization of this technology and explaining to the world how important it is, or is it going to be more of an organic, inevitable outcome that will take time?
This is just from my perspective, and this is just my view. I think we're in research phase right now, and it's our job to evangelize the research that's being done and push that scientifically forward. So ensuring that what we're putting out into the world is production ready with the acknowledgement of the limitations that it has today, and evangelize and educate people, but then also build systems where there is a benefit to participating in these systems. Arguably the most successful compensation for individuals platform right now is X or Twitter, but it's very constrained to a set number of people that have over 5 million views a month, so as they get big numbers that they then promote to kind of evangelize the fact they're getting paid for their data and revenue. So I think we're very early, and yes, it is our job to evangelize this. It is our job to die on the hill that privacy is important. That's why we're all here. But I do think we've got a ways to go, and acknowledging that is important.
I guess I'll answer the first question. So yeah, Game Plus is a pretty consumer-focused product because a lot of our AI is directly put into games. They're we need very, very fast response. So that's our major consideration, right? Is the cost and the latency of these encryptions work. For us, we're actually exploring a lot of different types of privacy technologies, like we said, T, MPC. We also have something that we're testing right now called TextShape, which is you can kind of encrypt and compress data, and what it does is it takes out any of the personal data that we don't really need, and it kind of filters out repetitive data, so it makes it easier, even more cost efficient for FHE to encrypt. So we're always exploring options like this. Want to have the fastest inference and training for our products.
What's the current question?
The main one, what technologies are you using right now, and your criteria?
So what we are using right now is mainly T and FHE. So I think I can answer both questions in the one answer actually. So that's actually when we talk about metrics about using what kind of technology, and also how to maybe educate your users to use them. And they're actually highly combined. For example, now all this technology, they are actually very distinguishable. For example, ZK is just mainly for reliability, FHE is mainly for computality, things like that. And they have different, I could say, accuracy, sacrifice, and cost, and also different, I would say, assumption. And then when it goes to how to choose different technology, I think they are from demand part, according to our customers' feedback. Mainly that depends. I would say I would divide that kind of demand to 3 categories. So first could be compliance, because although we are in a Web3 world, but actually nowadays there are a lot of Web3 projects. They try to targeting Web2 users, even the Web2 enterprise, and in which scenario those companies will be very concerned about compliance. Maybe they are working in a healthcare field or finance field. So that's would be, I would say, first priority. They may try to guarantee the security issues for the reason of compliance. And the second P could be the interest, because they could be a company who holds high value data. If you want to attract them to contribute their data to the Web3 world, and they may consider, okay, if I contribute the data out, how to guarantee my rights and also especially my right of benefiting from this data. So this could be second interest. And the last one could be preference. Yeah, I just want my privacy or security be guaranteed. And this is three main reasons. And what we are doing is like we develop a novel primitive which is called HSS. It can be regarded as a decentralized FHE to accelerate computing of FHE. And in the meantime, we actually combined with TE to guarantee its verifiability. So this is the metrics and what we are doing.
So let's get a little more personal. Maybe we can ask a question to each panelist, beginning with Kip. So congratulations on your recent fundraise and recent great news. So curious to hear a bit about where you're moving now, post this achievement, and where FHE fits into your plan.
So right now we're moving to Monty for our party this evening, so you guys should sign up and join us there. Following that, we've obviously got a lot of projects in the pipeline. There's a major one with Open Campus, so we're basically deploying an AI assistant chatbot for educators via their platform. And again, if anyone here is in the education space, we're actually managing their grant fund. So if someone wants a grant to do research, yeah, hit me up. So that is on the go. We also have another partnership, Moamate, and that is a Web 2 company. And they basically offer AI companions, which is there's the obvious AI boyfriend, AI girlfriend thing, but also stranger things and more hysteric things. So apparently they have people who are using it, veterans who went to the Iraq War who are using it to work through the PTSD and people who are talking to their parents who are dead and stuff. Strange things going on. But that is one of the cases that was just brought up now. The sort of, as people get more and more into interacting with the AI like it is a human and letting themselves go and discussing very personal things, then obviously encryption and security and privacy is going to be more and more important.
Next question for Game Plus. So, of course, Game Plus is pioneering a new decentralized AI protocol for the gaming industry, which is very interesting. Can you take us through where you see AI being implemented in games? I know a lot of people have been talking about it, but we've yet to kind of see big games use AI, so I'd love to hear from you.
Yeah, so one of the projects that we're working with, which I'm really excited about, is an AI version of Dungeons and Dragons. It's a game where pretty much every single part of Dungeons and Dragons you can put AI into, right? The main one is obviously the dungeon master, right? It's somebody who needs to be really creative, needs to plan out a story, needs to have all these different paths based on what the users do. This is perfect for AI. We're actually creating like a narration agent just for Dungeons and Dragons. And then especially within the game, there's a lot of branching paths, there's a lot of different ways that you can go. Maybe you want to explore a castle today, maybe after the adventure you want to do something else. This is all also procedurally generated by AI as well. So we see assets and NPCs as a very big part of game generation. Other than that, we're of course for the gaming layer and data, there's a lot of data generation inside these kinds of games, right? There's dialogue data, there's which paths you take, what you do, what kind of play style you have, and this is all very important data as well, and also sometimes very private. So eventually I see all these large companies using AI NPCs, generating AI assets, right? Which decreases the workload a lot as well.
Very cool. Are you seeing this happen in real time in the games, or is it pre-generated with AI?
Yes, it's happening in real time, yeah.
So next question for Morphic. So of course, Morphic's network with FHE and VCC tech stack is quite innovative. Maybe you can share a little bit more about the specific stack and also some of the efficiency considerations when it comes to your implementation on the tech side, and also your favorite security technology that you're using at the moment.
For short, actually, Morphic's, I would say, a very significant research-driven team, and actually we have a lot of experts in the field of FHE and the TE part. This is actually why we consider to merge the TE and FHE and to present that as a verifiable, decentralized FHE system. And here we actually, on the one hand, actually, as I mentioned, we use decentralized FHE to accelerate, to further accelerate FHE, because nowadays we have, for example, maybe the most popular FHE lab in Web3, which is TFHE provided by Zama, and a lot of projects are using that to build their project. And for example, the idea of the FHE lab, like TFHE, they actually were selling FHE by using parallelism, using the GPU or some dedicated, I would say, acceleration algorithm for example, polynomial matrix multiplication, just like NTT and things like that. But all the ideas that I try to accelerate FHE on a single subgroup model. I provide the subtypes to you, and then you accelerate FHE on your local platform, and then give me a subtype. So actually, our technology is like we decentralize this kind of computing system, and by decentralizing that, and we can actually conduct again Morphic encryption on independent node. But this time, because it's decentralized, actually we can use, for example, maybe the just partial homomorphic algorithm to conduct computing to accelerate that, and things like that. So this is the idea behind the decentralized system. And why we use TE here is like on the one hand, FHE itself has to be guaranteed with verifiability, because its own is not for verifiability. Just that MPC is not for verifiability. It's just for confidentality, and so we need to guarantee its verifiability. On the other hand, we have indeed got a lot of, I would say, demand for the efficiency. Yeah, that's really a significant demand, especially now there's a lot of Web3 DEI project in infra. They are working on, bringing the large language model on chain, which can say, over BD, and even, for example, Llama is biggest open source model with 70 BDM parameters. And so TE here actually matters, because according to your demand and according to our knowledge, to guarantee that kind of, as I said, a model big to that kind of degree, you have to use TE today. And here actually, according to our cost, I would say, VCC actually corresponding to, we would say, a secure solution using TE here. So by using TE according to our cost, actually we can guarantee the security, confidentiality and verifiability for large language model with almost zero overhead. So this is a big breakthrough of TE in this year, because nowadays we got a new type of CPU TE, and we also got a new type of GPU TE from different manufacturers, and they start to collaborate together to optimize some kind of IO overhead, things like that. And that's a new breakthrough happening this year. So in this, according to all this context, I would say for now, depends on the model. If that's a large language model, we may use TE to guarantee the security, and it is security. And for some kind of a smaller or more simple stereo, where you think you definitely need a more secure solution, okay, we will use HSS to guarantee the security. So this is what I'm doing, and the corresponding developments there.
That's great. Quick follow-up, how do you feel about the supply of TE right now? Do you feel that you can scale solely with TE? There's enough available compute out there that's TE enabled?
It's actually not very difficult. It's very important in this, I would say, in this architecture and design. And the good news is that, for example, we also, for example, we have a Panelist here who's working on GPU network, just in last panel, right? And there are a lot of this kind of DEI project who's working on, DP, especially GPU, and a keyword they usually mention is H100. So H100 itself is exactly a kind of GPU who can be used for both plaintext computing and also the TE. Just depends on how you use that in the software layer. So this that means actually it's very easy to accelerate different kind of GPU and from everywhere from different projects, and also for especially for CPU TE actually nowadays it's very interesting that Intel, AMD, and different cloud they all commit to this technical road to provide different confidential computing service and also the fundamental different the hardware, and also some projects are working on open source TE to solve some of the fundamental trust problems of TE in Canada. So that would be I think a promising technical road.
Definitely. So Masa is building a massive data scraping network with millions of data points. So take us through a bit about how important security is when ensuring that there is data harvesting that's private, that's not hackable, and also a bit about your business model, how you sell the data or how you provide it.
Yeah, and I'll start with the business model right now. We actually give everything away for free. So everything is completely open source, permissionless. We use our own incentive model and the incentive model of BitTensor to essentially fund this early stage. I think that in every startup's life you have this golden opportunity to grow with incentives or VC money. We are fully exploiting that to help builders get off the ground in what is a tough space and one that's competing against centralized AI that's moving extremely fast. So our business model right now is free. As demand for this finite pool of resources, which it ultimately is through this network, especially through Masa, goes up, there'll be a notion of like a gas fee like you have on Ethereum for block space. So the higher the demand, proportionally the cost for accessing the data through the network will go up. The cost for accessing resources for pre-processing data, maybe that's generating synthetic data sets that's modeled around private data that might be hard to unlock. Like we're starting to see a lot of evidence to show that model advancement with synthetic data is extremely valuable, especially for harder to extract data sets. So we think about privacy preserving technology, working with leaders in the space to, if we're using data or collecting data that's not available in the public domain, to ensure that that is secured privately and owned by the user. Like I really do advocate for prompt data, which I mentioned a lot of the time here, to be made available for training, but to be kept private. I think having our personal conversations private is very valuable and very important, but also having it available to train on is equally as important for moving these conversational models forward. So that's our position. Come build with us.
Of course. Just a quick follow-up question. It's interesting to hear that you're an advocate of synthetic data generation. It's a hot topic now. Take us through quickly, is there specific verticals or domains in the data realm that synthetic is good for? Is it good across the board? And where do you see limitations of synthetic generation?
I'll keep it really concise because we're getting 1 minute flash test. I think it really does focus on hard to extract, hard to aggregate personally identifiable information that could be medical records. That's where you immediately go. You have to remember a lot of these organizations move very slowly, like healthcare, anything that's regulatory burdensome is slow. So these are verticals of data that can benefit a lot from synthetic data generation. Prompts as well. There's an amazing BitTensor subnet that does synthetic prompt generation that iterates over multiple agents to get the best prompt, synthetic prompt. There's a lot of very interesting agentic workflows that can give rise to very valuable synthetic data sets, but specifically those hard to extract data sets that are often personal and private in nature can lend themselves to synthetic data set generation very nicely.
I think we'll close out here. Thank you so much everyone for the time. It's always so nice to get together with such forward-looking people. Thank